All right, so I'm gonna start. In your packet, you will see on, I don't even know what page it is. Let's see. Probably page 7-ish, sounds right. 1, 2, 3, 4, 5, 6, maybe page 6-ish. You'll see these special right triangles. So I just want to talk through them really fast. Your unit circle, all the values in the unit circle come from these special right triangles. So special right triangles are either a 30, 60, 90 or a 45, 45, 90. And so you either have this special right triangle or this one, which these are the exact same thing. And it's sine, cosine, and tangent for each of those values. And for every point along the unit circle to get there, there's some value of x and some value of y. I want to make the connection that cosine goes with x and sine goes with y. Here's the reason why. Because if you have a central angle, which just means that the angle is at the center, if you have a central angle, let me put a little theta. I'll make it pink so you can see it. If I have a little angle right here, thinking about the trig functions, I have sine would be the opposite. That's why sine goes with y. And cosine is adjacent, which is next to. That's why cosine goes with x. And so all of the trig ratios all the way around the unit circle, which you should have memorized by now, all correspond with that. The only one that doesn't match up directly is sine and cosine for the 45, 45, 90 triangle. If you just looked at the actual side lengths, the trig ratio is actually 1 over square root 2. But I already told y'all that back in the day, we thought we had to rationalize all of the denominators, and we don't really anymore, but it's still convention. So what you see is that they've turned 1 over the square root 2 into square root 2 over 2. That's how you memorize the unit circle. So this is the actual ratio, but when you rationalize it, it turns into this, which is what you memorized for the unit circle. So this is just that page. It already had a lot of this stuff already written on there up at the top. I was just kind of explaining some of this for you. And this is all assuming that the radius is equal to 1. So if the radius is equal to 1, the side lengths are 1, 1 square root 2 and 1, 2 square root 3 for my special right triangles, which is how the unit circle unit circle is created. So this you should have already memorized. Along the sides, you may memorize like what quadrants that things are positive or negative. I used to have my students come up with some kind of acronym, but it's basically ASTC. In the first quadrant, all of the parts of the coordinates are positive. All trig functions are positive. In the second quadrant, only sine, so only the second value. In the third quadrant, tangent is what's positive because you end up with negative over negative. And in the last quadrant, it's cosine is positive. And it also corresponds with like x and y when they are positive. So like when you move into the first quadrant to get to any of these points, both x and y are positive, which means both cosine and sine are positive. To get to the second quadrant, you're moving in a negative x direction, so negative cosine, but you're moving up, so positive sine. Negative, negative to get to the third quadrant, but tangent is sine over cosine or y over x, so that's why tangent is positive. And then in the fourth quadrant, you're moving in a positive x direction, but a negative y direction. So positive cosine, negative sine. But as you move around at all of those reference angles, did I remember to record? Am I recording? Does it say?
Yeah.
Okay. I was thinking I've already been speaking. I hope I'm recording. But all the way around, the coordinates are the same. So hopefully this is what's really important, that you remember what these coordinates are. You have to remember the coordinates. And so however you choose to memorize them, that is on your own time. There's a gazillion and a half videos that you can watch, however you choose to remember. So we good on the unit circle? That was your Thanksgiving break. All right, so now we're going to use it. And if you haven't memorized it by now, that is your tonight's homework. You will not be successful on the next test if you do not have that unit circle memorized and to be able to reproduce it quickly. And so make that a priority. From here, we're going to use it. We're going to use it. So these are questions out of the assignment, and I want to point out that all we're doing is finding this angle, and then we're looking for sine. Sine is always the second value. So x comma y is the same thing as cosine comma sine. So go find pi over 2, which is the same as 90 degrees. Pi over 2 is straight up. And what is the sine value? 1. Yeah, hold on. I'm just looking for my mouse. My mouse disappeared. Yes, the answer is 1. So you have to look for the angle, and this comes from the x, y. More specifically, let me put that arrow better. Because we were talking about sine. This is the y part of that coordinate. Let's do this one. Cosine of pi over 2. We're looking in the same spot. What's cosine? 0. So again, in the x comma y in that coordinate, it was the x value. Let's keep going. So tangent of pi over 3. Pi over 3 goes with 60 degrees, and I always remember because these are opposites. So pi over 3 goes with 60. Pi over 6 goes with 30. They're not the same. So pi over 3. So we don't have, I'm going to erase this so I can create it with you. We don't have tangent values listed, and I don't even tell you that you have to memorize the tangent values because you can easily create them. Tangent is always y over x or sine over cosine. You have to know that. And so since tangent is y over x, when I go to my pi over 3 radians, this is the coordinate. So it's square root 3 over 1. The denominators are the same. What happens when the denominators are the same? Because technically it's this fraction divided by this fraction. They cancel. So we really only have to look at the numerators. So I have square root 3 over 1. So out to the side, I'm going to write the tangent value. So this is just square root 3. So now tangent of pi over 3 is square root 3. Beautiful. Now the rest, these are reciprocal values. So the way you find reciprocal values is first you have to figure out who their pair is. So when I look at cosecant, who pairs with cosecant? Sine pairs with cosecant. Remember, there's only one co in the pair. So I'm going to look for sine of pi over 4. Pi over 4 is the 45 degrees. So what's nice about 45 degrees is that both sine and cosine are the same. So what is sine of pi over 4? Square root 2 over 2. But here's the thing. What was that originally? Remember that the original fraction was 1 over square root 2, right? I put it over here. That 1 over square root 2 from our special right triangle turned into square root 2 over 2? Yeah? Yeah? That's how it was created. So if this is what it was originally and we flip that upside down, what do I get? Square root 2. For cotangent of 0, so cotangent of 0, remember that is the angle. So I'm looking at 0 degrees or 0 radians. This is the coordinate. It's 0, 1, 0. So first I'm going to look at tangent. So tangent of 0. Remember, it's y over x, so it would be 0 divided by 1. So when I look at cotangent and I flip that upside down, it is 1 divided by 0. What happens when you divide by 0? Undefined. It's 1 divided by 0, which is undefined. So don't you have to look at the ratio and flip the ratio. So tangent of 0 is 0. So like off to the side, I could put 0 because tangent of 0 is 0, but it doesn't mean that cotangent is also 0. You have to look at that ratio and flip the ratio. Cosecant, again, who goes with cosecant? Sine. So I'm going to look for sine of pi over 6. I always remember that pi over 6 is in the same place as 30 degrees. So right here, pi over 6 and 30 degrees. What is the sine of pi over 6? 1 over 2. And so if I'm looking for cosecant, what do I do with that? So what is cosecant of pi over 6? 2. How difficult is this? Not very, right? But how accurate are you going to be if you don't have the circle memorized? Like these are pretty low-hanging fruit on the test, but if you don't have the circle memorized, you're going to suck at it. So you have to memorize that circle. Yeah. No, I cannot do that. Yes. No, I cannot give you a blank unit circle. All right, we're going to keep going. For these, I've picked a couple more problems that I would like to take an awkward amount of time to let you answer these, and then I'm going to put the answers up, and that's all we're done for today. So I'm going to give you an awkward amount of time. I'll give you 8 minutes to fill these out. So I'm going to give you an awkward amount of time. Mainly just because I feel like if people feel like they don't have enough time, they don't start it. They're like, oh, I don't have enough time, so I'm not even going to do it. So I'm going to set a timer, 8 minutes. And let's do it. Help a friend if they don't understand. Bella, did you memorize the circle? No. Then you don't understand. You have to memorize the circle. And it's not hard. It like is really looks intimidating because there's a lot of stuff there. But I promise it is doable. You are a smart girl. You can do it. You just have to sit down and watch a under 5-minute video on how to memorize the unit circle. But without it, you're gonna feel lost for like the rest of this unit. Yeah, forever.
Okay, well,
So it's like you have to make that number one. And then if you had this circle memorized, you would walk into today's stuff and you'd be like, I don't understand what you don't get to anybody that said, I don't understand.
we would have a 13.
Oh, you know why, Bella? Because I think because you were not here the day that we got out for break, right? You were not here before Thanksgiving break because you had to take your midterm early. Or you had to take some test early, right?
Yeah,
Maybe you were not here then. But you still gotta memorize them.
It's like, oh my god, that's so unfortunate. Anyway.
I mean, to be truthful, like you still just gotta memorize.
Dang, so everybody got a good start. Wow.
Yeah, and they learned it last year. Whoops, awesome. But listen, don't get discouraged. Tell her that she can do it. Like
can do
all
it.
you guys that learned it, you can do it. It looks
And
it,
she doesn't even know
it looks intimidating, but
it really is not bad.
it's not bad. You just literally have to sit down and force yourself to memorize.
Like you literally looked at. How is this?
Hold on, I have a unit circle.
How is this one? And it's
If
why.
you have to figure it out, you just have to remember that cosine is x and sine. So for like this one, cosine of pi over 3, pi over 3, cosine is the first value, the answer is 1. Cosine is the first value, sine is the next value.
Okay.
So for this one, pi over 2, I go up to pi over 2. Sine goes to the second value. Answer is 1. Tangent, pi over 4, so I go up to pi over 4. Tangent is this over this, well, they're the same, everything over is 1. Answer is 1.
So if it's tangent,
Guess why we're this.
what else? What is this? What the hell is cosecant then?
So do all the ones with sine, cosine,
And
and
tangent?
tangent. Go do those first.
Well, I gotta make my circle. Can you move that?
Yeah.
No, it's just off.
That's right.
So I'm gonna be.
I don't think that your homework comes with an answer key. All the odds. You're required to do all the odds. It's a big long homework, but they're so fast. These questions are so quick, no math involved. They're really fast.
Really, all of them?
All the odds. And they're easy to check. You could literally type it into any AI that you choose and you could get the answers. They're so easy to check.
Opposite. Secant you do cosine and
Uh-huh.
cosine you secant.
No, if it's cosine, you just do cosine. Yeah.
What's the other one? Numbers? Can be empty. What?
3 more minutes.
That's what I was doing. I was just looking all the odds. That's what I figured out. We have more than 6 problems.
That's 6, 7.
I need this.
Guys, not okay.
Yeah, I'm not going to. Yes. Give us one. There's one. Yeah, but she gave us two. She gave us we didn't give us one. No, she gave us seven. Did she not? Oh. Bruh. I don't know what's fun. Yeah. I'm so tired. That hard though. I literally I'm just really down. Yes, bro. I did not start doing that. Yes, bro. It's a Wait,
Shut up. It's about obesity in America. And that's the name of the document.
there was this girl that I went to middle school with that would absolutely like read
So,
Dude, that was there to talk about
Bias, yeah, and it didn't turn out exactly how I wanted. I thought it was a big weird. And then somebody else made this. I wanted to change it, but I don't wanna. He made it all on her own.
Wait,
and I
you know what you could do? Just remove the background on the dude. Oh, yeah, then you can be eating the food on the street. Yeah, remove the background. So, okay, wait, right? Ooh, what's the first thing? Same to keep. And it goes in here. Bro. Yeah, these are. Goes. I learned that in robotics. Guess how? Because none of these people know how to put anything to the background. Just the proper 8 on
Yeah. No. There's not really much to show. I mean, I would expect that on like the reciprocals, so like 68, it might be helpful for some of y'all to write out what cosine is and then you flip it, but some of you may be able to just do it in your head.
Girl, all I do is actually.
I know, I love to do this one. Not on team, I really like all that. Looking back. Oh.
That's over there.
Thank you.
All right, let's check our work. How did you do? Does anybody have any questions? Which one? Okay, number 18, we've got secant. So I'm going to look for cosine of 2 pi over 3, 2 pi over 3. All right, so I'm going to travel around my unit circle until I land at 2 pi over 3. It's the same as 120 degrees. Cosine goes with the first. Oh, here's a way that you can also remember who goes first. So in a coordinate, you have x comma y. Well, x is before y in the alphabet and c is before S in the alphabet. So that's one way you can remember who goes first. So I'm going to look for cosine. Cosine is -1/2. -1/2. And if I flip that upside down, I get -2. Kinsey, did I answer your question?
Oh, so you use the other fraction? Okay.
So secant goes with cosine. So I identify what is the cosine ratio and then I flip it. Any other questions?
Yeah, what the hell was sleeping? Both became phone family.
Were you here last class or the class before?
Yeah.
Were you sleeping?
Oh, I don't.
Yeah.
I'm not a liar.
No, that's okay. I appreciate honesty. Well, that's the reason why.
Oh, okay. Fuck it.
How'd y'all do? Yes. Yes. So tangent of 2 pi over 3. So we're looking at the same value as here. So tangent of 2 pi over 3, remember tangent is sine over cosine. Since the denominators are the same, they would cancel if I divided the fraction by the fraction. So I can just look at the numerators. So I end up with square root 3 divided by -1.
What?
So it's just negative square root 3. Cameron, does that answer your question? Okay. What other questions? Because you haven't been paying attention. I can't, it's not a quick answer. Like you've got to go back and rewatch the lessons. So I do want to point out question number 68. So for question number 68, secant goes with cosine. So if I identify the cosine ratio for 11 pi over 6, 11 pi over 6 is over here in the fourth quadrant. Cosine goes with the first value because C comes before S. So I get square root 3 over 2. If I flip that upside down, like I'm okay with you leaving it like this. But I will tell you, if you're using AI to check your answers, it's highly likely that they could rationalize the denominator. And if they did, it would turn into this. Just so you know. Question number 68. So we're pretty much done. I'm going to end this video and we're done for the day. You need to do all of the problems. Yep.
Now that we're done.